everyone, and welcome back to Women in Data weekly webinar series. My name is Rajvi Mehta, and I am the East Regional Sponsorship Lead here at Women in Data. This week marks the last week of our weekly webinar series. Before I introduce you to this week's speaker, let me thank each and every one of you for your generosity with time and the willingness to learn along with the rest of the community. We want to thank our speakers for taking out time from their busy schedule and sharing their knowledge and expertise with the rest of us. Times have been tough. We know that. We are hurting as much as you are. We want to do better. We want to be better. Our strength lies in this community. We want to make it a safe learning space for everyone. If you have any recommendations on how we can do that, please do let us know. This week's speaker is Gayathri Gopalakrishnan, who is the founder of Ecoformatics Lab based in California. She will be talking about using data for the benefit of the society. She specializes in data for good and is a scientist and an engineer working at the intersection of big data, sensors, and clean technology. She has 10 plus years experience in agriculture and crop modeling, water resources management, risk assessment, environmental remediation, ecosystem services, resilient cities, renewable energy, climate change, and sustainability. So let's get started with this week's webinar, and once again, thank you.
Hi everyone. I'm delighted to be here today talking to all of you at Women in Big Data. I'm Gayathri Gopalakrishnan, the CEO and founder of Ecoformatics, an education technology company that we started in 2018 to teach data science to people who are interested in helping solve the problems facing the earth today. So today, I'd like to talk about what happens when you have two very different sectors and two very different fields, clean technology and data science, and how you can build a career at the intersection of these fields. So a little about myself. I have a PhD in environmental engineering, and I have been working at the intersection of data science and clean technology for well over 15 years in various roles as a research scientist in academia, in national laboratories and state agencies, as a data scientist and engineer in several clean technology startups, and most recently, as a manager in Facebook's Sustainability and AI initiative. So let's get started. Before becoming a clean tech data scientist or engineer, the first question that probably comes to your mind is it worth it? If you're someone who's been in the data science field for a long time, is it really worth your time and effort to shift sectors completely? If you're someone who's a clean technology professional who's been working in air pollution or water or the energy sectors, do you really need all these tools, and how does that help advance your career? And that leads to the second question, which is, where can you find the jobs, especially now in the current circumstances with the economy tanking and the pandemic shutting down every country in the world? And then even if you do find a job, what kind of careers do you get, and how do you progress in this particular field? So what really are the needs in this sector when you're becoming a clean tech data scientist or engineer? And what can you do in particular? What skills do you have that you can already apply in this sector? And what do you really need to learn? So we're going to explore all these questions today. But let's start off with the first question, which is making this shift and building a career at the intersection of clean technology and data science really worth it? And that really brings us to the question of How big is the market? And what kind of jobs are there? So now we've all heard this quote about the data scientist being called the sexiest job of the 21st century. And there have been studies that have predicted that there'll be over 250,000 vacancies and more over the next 10 years. Now, together with this, if you look at the clean technology field, the market size in the top 5 clean tech sectors, which are energy, agriculture, water, climate, and sustainability, is predicted to double to $6 trillion by 2025. And that's just the top 5 sectors. So we're not talking about things like smart materials, bioengineering, all the other sectors that are coming up, forestry, everything which is going to be changing in the next 10 years or so, if not sooner. So we're really looking at a multi-trillion dollar, multi-billion dollar sector. And the interesting thing, at least in these times, is that all these sectors, agriculture, energy, water, waste management, smart cities, they are essential sectors. And we can't live without water and energy and food. So even in the tough times that we are facing, there has still been hiring. Maybe not as much as we had seen in the last quarter of 2019 and early 2020, but there's still been significant hiring, and that's expected to continue as automation and data science and predictive modeling become more and more important in the clean technology field. So where are all these jobs to be found? The usual suspects: in academia, if you're interested in research, in government organizations, and I've pulled up some of the main ones that are there in the United States, but there are the equivalents in all the other countries. For example, NASA or ESA if you're in the EU, the US Department of Agriculture, the military, including the Pentagon. So all kinds of agencies and government organizations. Then there are the large corporations. And this is not just corporations in the energy or agriculture or water or climate sector. You're looking at the large tech companies, Google, Facebook, LinkedIn, Amazon. You're looking at insurance companies because climate change is making insurance a more dicey business these days. And they really need to figure out how to incorporate climate change into their predictions. So you're seeing a lot of sectors and a lot of companies start looking at using data science and predictive modeling in their work. Startups, always a good place to be because there are a ton of new startups, especially the ones that are looking at using smart sensors, IoT, and predictive modeling in the clean tech field. Consulting firms, the big 4 consulting firms that are specific to the environmental field or the agricultural field, all of them are now beginning to look at expanding their offerings to include data science and solving clean technology problems using data science. Finally, being an entrepreneur is always an interesting opportunity. There are plenty of problems that need to be solved in this sector, and this is one of the fields where starting a company may actually pay off big time over the next 10 years. And finally, a sector that you don't normally think of, which are nonprofits. So organizations like the Nature Conservancy, the World Wildlife Fund, National Geographic, they all use data science. They all use sensors and satellite data and predictive modeling to try and figure out how the environment is changing, how wildlife is behaving, how humanity is impacting the earth, and what we can do about that, and how we can help mitigate that. Of course, they don't pay as well as corporations in the other sectors, but if you're looking for a change and interested in working with them, they're always a good opportunity to be at. And then what kind of jobs are there? Now that we've looked at where the jobs are and how much the market is growing, what are the jobs like? So, like any other field, there are the technical jobs and the management jobs. And in the technical roles, it's the traditional data scientist, data engineer, analyst. But in the clean technology field, you'll also find some very sector specific roles, which are people who have been building models and generating data in the field. So agricultural engineers, water modelers, people who have been working and in the sector, in the particular area that you're interested in, and have a great deal of expertise. Now, if you're working in management, in general, it's not very different from any other sector, except that it's probably a good idea if you have a fairly strong knowledge of the clean technology sector that you want to work in. So if you're an energy professional or someone who's working in the water field or someone who's working in the agricultural field, and you have the contacts in that area, you're probably much more likely to be successful than if you're coming from a completely different field. And then finally, there are the technical management roles, which could also lead to the higher management roles in larger companies. And these are where people who have a combination of technical expertise and are interested in management skills can be employed in. These are again found in almost all large organizations. And finally, something that maybe a lot of people don't think about, but most companies working in the clean tech field have a finance market, a sales department, have a marketing department, and need analysts and quants and people who are capable of understanding the data and helping to improve their interactions with their customers. So even if you're not exactly in the clean tech sector, working in these departments could actually give you a foothold into helping use data science to solve problems facing the earth. It's a way to get started, and it's a way to build into working into more technical roles if that's what you choose. So finding these jobs and the kind of people who get hired in these jobs really depend on the skills that you bring to bear. And that means that you need to figure out the question of which sector are you coming from? Are you somebody whose skill set is primarily in the clean technology field? And that, as you can see, the clean technology field covers a vast number of sectors. It's agriculture and food, energy, the environment, looking at climate change, smart materials, smart cities and urban sustainability, water, air pollution, disaster-related work, a whole suite of fields. So typically, if you have a degree in one of these fields, and it could be a master's or a PhD, you've worked in the sector for a long time, and you're capable of building and understanding the models that are sector specific. So for example, if you're working in the agricultural sector, you know how to build a plant model. You know how to build a crop model. If you're working in the water sector, you understand how rivers flow. If you're working in climate change, you can evaluate the climate models, you can tweak the parameters, and you can downscale the models to look at effects at global, regional, and local levels. If you're someone who's coming from the clean tech sector, then you probably need to figure out what data science skills are really useful to you and how can you pick them up. On the other hand, you may be someone who's coming from the data science field. And again, data science covers a really large number of sectors. While you can think about data science as being typically data access, so getting the data, which would be from sensors or satellites or other devices, processing the data, which is data engineering, and that's how do you store the data, what kind of security do you have, how do you access the data. Then comes all the modeling, which is machine learning and using remote sensing, spatial and temporal statistics. And finally, data visualization, which is how do you create dashboards, how do you build maps. So there are really a large number of skill sets that you can bring if you're coming from the data science side. But it really boils down to, again, are you a modeler, are you an engineer, or are you an analyst? And finally, if you're the really rare person who has both a very strong background in clean technology and has been building data science models, then you're pretty much a unicorn and you're perfectly balanced. And you're very difficult to find, and you're probably going to be snapped up by a number of different organizations. But usually, as we've all figured out, if we've been working in the data science field, it's kind of hard to find someone who has all these skills. It's hard to find somebody who has a strong sector-specific background, in this case, who understands the clean technology sector, who can build machine learning models, who can build statistical models, who can do data engineering at scale, and who can build pretty dashboards. They're all different set of skills. So when we are looking at solving problems in clean technology, we usually do break them up into the kind of different roles that various members of a team would need to play. So you would have someone who's a very strong clean technology background, so somebody who either has a PhD in water or in environmental science and has been building models in the field for a while, maybe doesn't have as much of a handle on machine learning models, and that's where you'd get a pure data scientist. So somebody who can help with the machine learning models, who can help with building the predictive tools that you need. You definitely need a data engineer, because the chances are that if you let your data scientist loose on your data engineering problem, you're going to need to fix that later on, because the data scientists typically like to build the models, not make them easy to use and robust and reliable and improve speed and secure and all the fun stuff that comes with data engineering. And finally, there's the whole business analysis, data visualization aspect of solving problems. And that's again where you need somebody who understands the domain and maybe doesn't have a PhD, but can still figure out what the data means and can help build a business case for what you're doing and develop the problems that need to be solved. And that brings us to the question of what kind of problems typically need to be solved in this sector. So where is data science used in clean technology? Now, as I mentioned earlier, you can think about any organization or any problem as broken up into four main sectors, the first of which is operations. Now, as an example, if you think about agriculture, operations here would involve moving machinery. How do different farmers sell or rent their machinery? How do they interact with each other? What kind of labor do they use? How can you optimize getting the machinery and the labor where it's wanted? And that, for example, is a problem that the Startup Farmers Business Network is trying to solve in the United States. And there are similar startups and similar departments in organizations and companies all over the globe. Then the second aspect comes in finance. Understanding fraud, understanding the financial aspects of your clean technology company is always going to be useful. And these days, being able to build predictive models, being able to use anomaly detection to catch fraud, to detect fraud, and being able to build secure payment systems and figure out how to make the financial aspects of your technology company work is about as important as actually solving the problem. And then we come to how do the customers like what you're building? And that again comes down to looking at how customer segmentation works. So how do people respond to various aspects of the problem that you're solving? How do they work? Are there things that they need? What are they thinking of? And this again is something that is common in many fields. So experience in another sector can very easily be translated into the customer service department in a clean technology company. And then you come to the very specific problems that are there in clean technology. For example, if you're working in agriculture, how do you predict yield? How do the farmers look at nutrient availability? If you're working with a water company, a utility company, what kind of treatment options are being used in your water treatment plant? If you're working with a state agency, how is water being used by the different customers that you have? If you're working in insurance, how is climate change impacting your business? Which are the areas where it doesn't make sense for people to live and work anymore because they're going to be significantly impacted in the very near future. So all these problems are where you need somebody who has a very good understanding of the sector and who can actually build the models and do the hard work of analyzing the data and figuring out what exactly the data means. So when you look at all the different areas in which data science can be used, operations, finance, and customer experience are where if you have a background in data science and you have been doing similar work in other companies, you can probably translate it into the clean tech field. For example, if you've been at Amazon and you've been working on Amazon's fleet operations, moving to an agricultural company where they're looking at fleet optimization for farm machinery isn't too big a stretch. Being able to build a crop yield production model maybe is a big stretch. But actually working in the firm and getting to understand what the business is and helping to solve those problems is still going to be easy. And that brings us to the kind of data that you see in clean technology problems, because if you're a data scientist who wants to work in this field, you can't do it without understanding the data. Now, data for most environmental problems, most of the problems in the clean tech sector, whether it's energy, water, agriculture, climate, is spatial and temporal. And because the data is distributed across space and time, it's a little trickier to handle than the typical data that you're faced with. Because historically, most of the data that you will find available has been collected with using sensors at specific time intervals. So that means that the data is temporally and spatially more limited than what you would see, say, from an internet, from a Google search, or from a web app. And that makes it more challenging to deal with. Another issue is that the data is at multiple scales. So if you're looking at a climate change problem, for example, you're typically going to see the whole span of these skills. So you're going to be looking at global models, national, regional scale models. You may even be looking at some very site-specific models. So the kind of data that you have available is going to scale across all these regions. And that's another thing that needs to be kept in mind, because figuring out how to combine these different data sources and what the impacts are when you have data from different scales, what the holes are, how the data interact with each other becomes important. And then finally, if you're building a machine learning algorithm, the validation data sets tend to be small. So if your training and testing data may be a little larger, but your validation data, for example, crop yield will typically be once a year or maybe twice a year. If you're looking at how contaminants vary, they're going to vary across seasons. So your air pollution in winter is going to be different from your air pollution in summer, but you're not going to have as much data. If you're lucky, you'll get 30 years worth of data, which means 30 data points. So those are small data sets as far as validation goes. And typically they have low spatial coverage, so that is improving. So where can data science help in solving these problems? Now, first and foremost, it can help in filling in gaps in spatial and temporal data. Now, this is where a lot of the work in using satellite data and using data from drones, smart sensors, phone apps is coming in. And this is probably the lowest hanging fruit at this point in many of the clean tech sectors, because understanding and getting more data helps solve quite a lot of problems fairly quickly. A second area is in optimizing different operations. So if you're looking at minimizing water and energy use, for example, or if you're walking through a wastewater treatment plant and you're looking at optimizing the plant operations with the level of workforce that is available during the current pandemic. Those are the kind of things that you can build optimization models for. And finally, looking at building better predictive models. If you're combining new data with system models and machine learning and different combinations of statistics and deep learning algorithms, plant models, for example, or water models. So all this can help make better predictions. And this is where you'll typically need a combination of clean tech expertise and data science expertise. Another aspect where data science can help is in building better visualization tools. And this is something that, again, we are seeing a lot more of, because environmental data has tended to look a lot less pretty than what you would see on Google Earth now, for example. So building the better visualization tools so that people can look at maps, farmers can look at maps, operators working in water treatment plants can look at what their treatment plants are like and figure out what's going wrong very quickly is actually one of the most important problems to be solved. And finally, just by making access to the data more universal and making the data more transparent helps solving problems related to the environment and the earth enormously. Because as more people become aware of what the data really is telling them, that helps them understand how their actions can impact what's happening around us. So that's the broad picture. And how does that relate to specific problems that get solved? Now, the kind of problems that most data scientists working in this field face can be broken up into three main categories. The first is doing single time analysis. So you're looking at data, say, at a point in space and a point in time, and figuring out if it's worth your while to explore the problem further. So this is figuring out what questions can be answered, looking at your data. And this happens even before you build the model, machine learning models, or anything else. This is just basic data understanding and data analysis. And then, if it looks like the problem is worth solving, we come to the data engineering aspects, which include getting new data streams and figuring out how to analyze the data. So if you're getting data from a satellite or from a drone camera, you need image processing algorithms to analyze them. If you have new hardware, you need to know how to get the data from that and make that consistent. So that's getting your data streaming across space and time. So getting multiple data points, getting multiple time series, and using that finally to build your models. And this is where you use a combination of statistics and machine learning algorithms and models that are in the domain to help solve your problem. To give you an example of the kind of problems and the kind of skills that are needed, let's take a quick look at this. Now, these are two maps. The first one that you see with a lot of red in the upper half of the slide, that is a map of China and the air pollution, the nitrogen dioxide levels that are measured from satellite data over China. And you can see that the highly red zones are where there's a lot of pollution. Now, the map that you see below is what happened after the pandemic started and various Chinese cities were shut down. And you can see that the nitrogen dioxide levels in the same month in January dropped drastically in 2020 compared to 2019. Now, this is an example of a single snapshot of data that's been taken for over a month for a single country. We're not drilling down further or anything. We're just looking at this data to analyze the effects of what the lockdown has had on air pollution. So this means that the people, if you want to build these kind of models and answer these questions, you need to understand air quality models. What does nitrogen dioxide level mean? What are dangerous levels? How is it impacted by weather conditions, by airflow? Is satellite data equivalent to ground level measurements, which are what you're really worried about? How can you put that all together in a map, which is GIS? How can you analyze the data statistically? Because spatial data is very different since it's not independent and identically distributed. So how do you account for that? How do you build the model that can analyze spatial data? How do you look at time series data? How do you find anomalies? How do you find the hotspots? So these are all things that somebody with a clean technology background and working in the air quality field would be able to bring to the table. Or if you're someone who's a data scientist who's looking at this, you would probably want to at least get a sense of what exactly air quality models are and what they're telling you, even if you don't dig down very deep. And if you are someone who's coming from the data science side, what you would be bringing here, for example, would be machine learning and statistics and data engineering. So these are two snapshots of data. What happens if you build a pipeline so that you can start tracking which areas actually are the most impacted as the lockdown is lifted? So that would help identify the biggest polluters. And that's something that having a large stream of data, being able to visualize the data, make it clear, being able to build a model that can predict that would be really, really important. So combining these different skills will help you solve problems like that. And that in turn would bring you to the different kind of jobs that are seen. So just to give you examples of different jobs that have been advertised over the last year or so, you could be somebody who's coming from a data science background, like this particular role, and your computer science and your algorithm skills are the key features that are needed, rather than understanding the clean technologies are really well. How do you understand the data, and how do you get the data, and how do you build the model? Or there could be roles where you really need to have the expertise in the clean tech field. For example, in a company like John Deere, an ag company, where you need a PhD for this particular role. They're both data scientist roles, but as you can see, in one of them, you need a PhD in agronomy or environment with some knowledge of data science and machine learning. In the other role, you need a very strong background in computer science with some knowledge of urban sustainability and the clean technology. Or it could be in management roles, like this particular role in Facebook, where you're looking at visualization experience and understanding the sector. Or someone who's at a director level role in a clean tech company like Climate Corporation, where you need to understand both the sector and data science, but you also need your standard management skills, such as people leadership and people management and vision setting and all that fun stuff. So to wrap up, as you can see, data science in the clean tech sector is a field that is exploding. And it's going to continue to explode even during the pandemic. Because, for example, you can't shut a water treatment plant down, even if you don't have all the workforce that you need. But what you would be looking at is figuring out how to monitor your water treatment plant remotely, so that you need to bring fewer people in and expose fewer people to the virus. And that's just one example. So the clean tech fields are essential. They are solving important problems that can impact the lives of billions of people. And using data science and machine learning is definitely going to make a difference and lead to careers. But in order to build those careers, you need to either figure out whether you want to be a technical person or go into management, or do a combination of the two, and where exactly on the balance you sit. So are you coming from the clean tech field with a really strong understanding of the sector and picking up data science skills along the way? Or are you a data scientist who has some knowledge of the sector and can deal with operations and finance and customer engagement, and you know whom to hire or whom to work with in order to solve the domain problems that you're facing? And finally, just understanding the data and the types of challenges that you're going to face, and what data science can actually be used to solve, and what it cannot be used to solve is critical in making careers at this intersection work. So finally, thank you for doing this, and I hope you'll check out our website, where we have a number of free courses and a number of posts that talk more about the intersection between clean technology and